if you are in somewhere else that's the other side of that date line, like Australia. And if you're in Australia, good day. My name is John Elliott, and today we are going to talk about the challenges of managing JavaScript e-commerce. I am going to give it probably about 30 seconds, maybe 35 seconds before I start properly. Just some housekeeping is that I'll present for probably about half an hour. This presentation is about 28 minutes. Then we'll have a Q&A afterwards. If there's any problem with the live stream, like something's gone wrong and no, you can't hear me, not that I pretend that you can't hear me, then put a message in chat and my colleague at JScrambler will try and fix the problem very quickly. So today, what we're going to talk about is the challenge of managing e-commerce JavaScript. Something that's really close to my heart. I've been worrying about this problem since I was at Visa back in 2014, and I gave this presentation at the PCI community meeting in Dublin only last month in October. It went down really well. Lots of people came up and asked me questions about it afterwards. Lots of people said, "Well, I wish my colleagues could have seen that," which is why we made this again. So if we can swap to the slide presentation, let's begin, because people should have managed to log in by now. Great. And so hopefully, if I press this button, the slide will advance. Yep, that's great. So yeah, if we've not met before, my name is John Elliott. I'm a security advisor at JScrambler. I've been doing PCI, when I put this presentation together, I've been doing PCI things basically far too long. I started off as a QSA back in 2010. After a couple of years of being a QSA, I moved to being Visa Europe's brand representative to the PCI Security Standards Council. So I was on the working groups that took PCI DSS from version 2 to version 3. Then after Visa Europe joined Visa Inc., I moved to a very large merchant, actually EasyJet in the UK, where I took them through PCI DSS and did lots of information security at a merchant. Then I went to MasterCard, where I was their representative to the PCI SSC as we moved from PCI DSS version 3 to PCI DSS version 4. And when version 4 had been finished, I left MasterCard and joined JScrambler, which is where I now am. So 13 years of DSS experience, a lot of it writing the standard. When we talk about PCI DSS, we often talk about it as a standard that involves people, process, and technology. And often when you do these presentations or you attend these presentations, people talk a lot about technology. I'm going to talk mostly about process today. I want to start off, first of all, by saying that by defining the problem. And the problem is this, that firstly going to look at it from a technical angle. And the technical angle is that any JavaScript on the page has access to any page element. And that means it can read it, it can alter it, and it can steal it. It also means that it can get hold of any data that's been entered by the user. It can get hold of any data that's displayed on screen. It can get hold of any events. By an event, I mean that the cursor moved out of one field to another field, or the mouse moved, or something like that. And then finally, it can also get hold of the URL and potentially some cookies, depending how those cookies have been defined. So given that, it can then also send any data where it's got anywhere. It can hijack those events. So it can hijack the mouse moving, or it can hijack the submit button. It can add extra code to the page, and it can change the behavior of the page. And so that's the technical problem. From the practical problem is that nowadays, web pages are basically assemblies of JavaScript that come from lots of different locations. If you see me present before, you'll know I keep presenting these slides, and basically that any web page now includes JavaScript from lots of places, from potentially from the acquirer, from your website, from third-party websites, and from tag managers. And those tag managers have got tags in there. The JavaScript might be doing things like it might be a framework, it might be a library, it might be a chat function, it might be a little window at the bottom that says, "Hello, do you need some help with this?" It might be A/B testing, it might be user behavior, it might be calling APIs to get shipping information, or to work out tax, or to work out how to do a payment. And it could also be things in tag managers for marketing, social media, analytics, and advertising. And one of the big issues is that it's just basically the number of scripts that's on every page nowadays. We did some research last year, and we looked at the top 20 e-commerce websites in the US and in the and in Europe. And on average, sites have 100 different bits of Java, 100 different loading, 100 different JavaScripts. On average, about half of them come from the merchant themselves, and the other half come from third parties. And of those third-party scripts, about they come from on average of 13 different domains. So that's 13 different locations where JavaScript's being pulled into the consumer browser. And the highest we saw was 35 different domains. So that's the practical thing, is that now websites are just collections of JavaScript that come from your website and lots of other websites. Um, and the problem we see now for the threat is that basically most criminal attacks against e-commerce, obviously not face to face, are JavaScript attacks that skim cardholder data out of the consumer browser. And the attack's really easy. The criminal just needs to get their criminal JavaScript into the website, into the page as it's rendered in the consumer browser, which means the attack surface is anywhere where the browser is loading JavaScript from, which could be one of really, well, it could be your website. It could be JavaScript loaded from other people's websites. It could be JavaScript loaded from a tag manager, and it could be JavaScript that the tag manager tells the browser to load. So first-party scripts, third-party scripts, and those fourth-party scripts. If you've not met tag managers, let me tell you what quickly. Let's do a little diversion into what a tag manager is. And a tag manager is a piece of JavaScript code that you add to your website, and then there's a user interface like the marketing or the digital department use to say, oh, I want this tag, and I want this tag, and I want this tag. Now, tag is a posh name for another piece of JavaScript. So a tag manager is really a JavaScript manager that can then load lots of other JavaScript. The idea was, and this is the lovely way that Adobe puts it, it shortens development cycles. It means developers don't have to keep adding this JavaScript to the website. They just add the tag manager, and then the tag manager can, under the control of marketing or digital, add lots of other bits of JavaScript to the website. So I describe it as a system that's designed to get information security and change control completely out of the way so that the marketing and digital departments can add any random JavaScript from anywhere on the internet to an organization's website. They didn't call it that. They called it a tag manager because they reckoned, I think it was the best piece of marketing ever, because tag sounds like a nice thing. It sounds like something social media, but actually it's a way of putting third-party JavaScript on your website. So here's the summary of the problem. Every piece of JavaScript's got access to any page element. There is no sandboxing or segmentation in a web page. The web is now built by pulling in JavaScript from lots of places. The attack surface is now not just your website, but any website where JavaScript's been pulled from. And this is now how we're losing most card data from e-commerce environments. And so given that, PCI DSS 4 has some new requirements in there that aim to reduce the risk. I'm going to look at the first of those, which is a preventative or a protecting requirement, which is this. It's that all payment page scripts that are loaded and executed in the customer's browser have, well, let's make it simpler. They have to have an inventory of it. They have to be authorized, and you have to work out why they're necessary for the functionality of the payment page. You might think, well, that sounds like a GRC tick box compliance requirement. And you'd be sort of right, but you're also sort of wrong, because the reason the requirement was written like that was it was deliberately designed to make entities understand and reduce the attack surface. We saw a lot of attacks over the past few years where JavaScript had been attacked, and no one really worked out why that JavaScript was on the payment page or who put it there. Maybe it was added 2 years ago and then forgotten about, or it was a library that somebody used once for some user interaction, and then that person left the company, the library is not even used anymore, but it's still on the payment page. And so the idea of having an inventory, that it was authorized and somebody worked out why that JavaScript needed to be there, was to have people consciously put JavaScript on the website, not unconsciously have JavaScript there. And then the last point in 6.4.3 is to make sure that the integrity of JavaScript is validated. In other words, that you haven't deliberately put malicious JavaScript on the website. So that's the basics of the requirement. It's designed for people to knowingly put JavaScript on the payment page, not accidentally. It has to have some process behind it. And so if you're a technical person, you probably think to yourself, well, that sounds like we need a workflow, and a workflow that sort of looks like this, where the business decides to begin with, excuse me, that they want to add some JavaScript to the website. So they do that, and then they write the necessity of like why it's needed. Somebody in IT needs to check it's not malicious. Then, like, is it authorized? And if it's not, I guess you go back to the business and say, well, that wasn't authorized. But if it is, you record details of the approval. You then update the inventory, and then you add the script to the web page. So a basic, simple workflow. And then if a script, a JavaScript changes, then I guess there's a request to change the script. Then we need to document the necessity. And do we need? Yeah, we probably do need to document necessity if the behavior or the functionality of the script changed. But if it was just like adding a comment or changing the way some code was written, but it didn't change the behavior or functionality, you probably wouldn't need to document the functionality. But let's assume you do. And then you'd again work out whether it's malicious or not. Assuming it's not malicious, is it authorized? If not, back to the business. And if it is authorized, then you'd record the details of the new approval. You might update the inventory to say that the script had been updated. And then you'd add actually, because you don't need to add the script to the page because it's a change. You're probably just changing the same file. The browser will load the new version of the script straight away. So you don't really need to add the script to the page. So if you're looking from a workflow perspective, that's what the workflow would look like. Now, you can meet the requirement 6.4.3 and 11.6.1 deliberately. You can use two bits of free technology that are built into the web protocols called content security policy and sub-resource integrity. Let's look at them both individually first. So content security policy, or CSP. It's ideally set in the HTTP header of the website, and that's something that's set in the web server configuration. And the idea of this is that if an attacker gets hold of the file system, i.e., they can change the HTML files, they still can't change the HTTP headers because they'd need some admin privileges on the web server management interface itself. And using the HTTP header, you can restrict where the consumer browser can load JavaScript from and where it can send data to. And so the really simple one is it says content security policy. Here's an example. Default source is self, i.e., you can always load stuff from your own first party site, and you can only also load scripts from safescripts.foo.com. So you can restrict where the consumer browser, able to load scripts from. So in this case, the browser will be able to load them from the merchant's website and from safescripts.foo.com. So if we look at our existing workflow and say, well, how do we implement CSP in here? It's pretty easy that once we've updated the inventory, before we add the script to the page, we need to update the location that the JavaScript's coming from in the CSP command. We have to change that CSP command in the headers on the website configuration. And CSP is a really powerful tool because if you implement it and the browser sees an instruction, maybe the criminals hacked the HTML to say, load my criminal JavaScript from X. If X isn't in the CSP, the browser won't load it. So it's a really good technique. The second is sub-resource integrity. And sub-resource integrity is also really clever. It's built into every web browser, well, almost every web browser, apart from very old ones. And so sub-resource integrity, what it does is to the commands that loads the script, it adds a hash of the script. So you take the JavaScript you want to include, you run a hash against it, and you generate this hash. This is a SHA-384 hash, and you put that in the command, the tag to load the script. So script source, there's the script, and here's the integrity value. When the consumer browser loads the script in, it recalculates the hash itself. It compares the hash that it's calculated with the hash that's in the tag, and if the two match, the script runs, and if the two don't match, the script doesn't run. And so if we're trying to add that to our workflow, after we've updated the CSP headers, we need to go and generate the SRI hash and then put the SRI hash into the web page with the hash in it. And so that's CSP and SRI together. Now, what about change scripts rather than new scripts? Well, a change script for CSP, we don't really have to do anything because if the script has just changed, it's coming from the same location, we don't need to do anything. If we change a script and we're using SRI, then we need to generate a new SRI hash every time we change the script and then update the page with the new hash values. And I guess the question is, well, what's the problem? That seems to work. And for some organizations, just using CSP and SRI will work. And the standard was deliberately written. You can tell the standard's deliberately written that CSP and SRI meets the requirements of the standard. The problem is that if you've got 100 scripts to manage, half of them from your website, half of them from third parties, it becomes quite complicated. Um, New scripts are actually not so bad because as long as we've got some sort of workflow here. The thing I want to highlight on a new script when we're using CSP and SRI is where does this request to add new script to the page come from? I mean, who can add JavaScript to the page? Is it marketing? Do they do it via a tag manager? The development team? Is it IT operations? Is it website management? Who's in charge of adding new scripts to the website? Um, I'm going to give you some action points to take away. But let's go to the first one so you can tell because it says action on it. These are things that I'm recommending that you do to get your arms around how your organization manages JavaScript. You can download a copy of the presentation and the recording at the end, so there's no need to take pictures of the screen. But so the first thing I would recommend you do is work out who in your organization can add JavaScript to the payment page, work out how they do it, and is there a change control process or can you enforce a change control process? So for first parties, that was for new scripts. On first party change scripts, the job we have to do there is to make sure we generate a new SRI hash when the script changes. And so again, back to the actions we need to do is like, firstly, does it actually get generated dynamically? I've seen some web server not libraries, like some web server instances, um, use systems where they generate JavaScript on the fly and then add the JavaScript into the page that's being rendered to the consumer browser. So you're probably not going to be able to use SRI for that. So, do you have any of that automatically generated JavaScript? You're using a web server technology that does that. Otherwise, who in your organization can change JavaScript? Do they make a request? Do they just go and do it? Is there a change control process? Where would you be able to update the hashes? Um, and if you have an automated continuous integration, continuous deployment pipeline, you could probably do that in that pipeline. And finally, is there an automated QA process so you could check you didn't break anything? And if you're thinking, did John just ask for an automated QA process? I did. And the reason is that SRI, if you don't get it right, if the hashes don't match, it fails silently and the website might stop working. And that, in my experience of running a very big e-commerce website for a very big airline where we're taking thousands of transactions a minute, when that stops working, people get very cross in the organization. And so if you're using SRI, you need some automatic checking there to make sure that the hashes have all been updated. Because unlike CSP, if CSP fails, it can send you an error message. If SRI fails, it just fails, so the script doesn't load. What about changes to scripts now then? So we looked at first party changes. What about third party changes? Remember, on average in our research, most websites had about 100 scripts, of which about half, so that's 48, so let's say 48 scripts, came from about 13 different third parties. And so if we look at our workflow, here it is, there's our request to change the JavaScript. And you look at that and you think, well, hang on, that's third party JavaScript. That's probably nonsense, isn't it? Because the third party is not going to ring us up or send us an email and say, oh, I'd like to change the JavaScript. I need to let you know because you might be using SRI or something like that. Because they're not going to do that. They're not going to have everywhere that's using their JavaScript in their change control process. In fact, the whole reason that people give you a bundle of JavaScript to talk to their API is that they can update it without really telling you about it. So, here's the next action point is if you're using third-party JavaScript on your website, I mean, I asked the question, would all the third parties notify you via the change control? The answer is no. Will they send you a copy of a new one in advance so you can regenerate the hash? Maybe. Will they wait until everyone's updated hashes before they then actually update their piece of JavaScript? It's doubtful. And they might also be using stuff that generates it dynamically. And so, unfortunately, if you're using a lot of third party JavaScript, SRI becomes pretty unworkable. Um, this is my made up graph. The scale is just like, ooh, that's hard, or ooh, that's large. And so, as you see, there's more risk and more complexity with third party script than there is with third party script, and the change control is also harder with third party than it is with first party. And so the next action thing I'm going to ask you to do, or recommend that you do, if you have to get your arms around managing JavaScript in your organization to meet these two new requirements, is work out what your current process is for adding JavaScript. Then work out what your current process for changing JavaScript is. Is there any automation in there? Are there any dynamic scripts? And you will probably end up with 4 business processes because it's not the same for first and third party. So you might end up drawing 4 different business processes. Your organization's business process when it wants to add a new first party script, when it wants to change that first party script, when it wants to add a new third party script, and then when it wants to change a third party script. So you might end up, as I say, with 4 business processes. So how do you do this, especially if you're using third party JavaScript and it's going to change and you can't use CSP and SRI? The first thing I want to say is that all organizations are different. I've given you 3 examples here of 3 different entities. So I use entity because entity is the word that the PCI DSS uses. It means the person who needs to be compliant, whether that's a merchant or a service provider, but entity. So like the first one's got 25 first party scripts. They're properly managed by the dev team, nobody else. It's in a CI/CD pipeline. There's one third party script from the payment processor. They could probably quite happily use CSP and SRI. Entity B, 6 first party scripts. It's part of a framework, very strict change control. They could certainly use CSP and SRI for those, but for the 35 third and fourth party scripts added by tag managers, they're probably not going to be able to use CSP and SRI and will have to do something about that. Now, one thing they could do is just take that off the payment page. That would fix the problem, and that's sort of the intention of the standard. And then the third entity, where they've got 200 first party scripts that are dynamically generated and 120 third and fourth party scripts that are added by marketing, they're not going to be able to use any of that. And NTC is a real company. That's a sort of snapshot of one of the organizations when we did a survey of these 20 e-com companies in Europe and 20 in the US. There was one that had 200 first-party scripts, but they're obviously dynamically generated by the engine that makes their website work. So I want to remind you of the 2 requirements, 6.4.3. And the key thing is that it says, a method is implemented to confirm that each script's authorized. And 11.6.1, so that's the detection part of the new requirements, is the detection is to alert personnel to unauthorized modifications, not all modifications, just to unauthorized modifications. And the focus very clearly on the standard is managing JavaScript. And so the focus is that is about authorization. New scripts need to be authorized. Changes need to be alerted when it's unauthorized. It's very important that the standard does, in fact, let me cross this out. The standard does not say unauthorized scripts must be blocked. There's no requirement in the standard to do blocking. There's no requirement to block unauthorized scripts. Now, some tools you can buy will do this, including JScramblers, okay? But it's not a requirement in the standard. So if you hear people say, oh, you have to block unauthorized scripts or you can't load unauthorized, standard doesn't say that, okay? And so what I have discovered in consulting to a lot of organizations that are looking at this problem is that typically you need to think about different authorization processes. You might do that because based on the 4 workflows we've got of new first party changes to first party, new third party changes to third party. But you need to think about the fact that you might have different authorization processes for different sets or classes of scripts. And the 3 authorization processes I want you to think about are default authorization, pre-authorization, and post-authorization. So default authorization you can have in place for low or zero risk changes. And what I mean by that is 11.6.1 talks about unauthorized changes to anything on the website. But you might say, well, actually, by default, all image changes are authorized. By default, all HTML changes are authorized. By default, all scripts that come from that vendor who we've done a whole lot of due diligence on and checking, and the scripts are coming from a DSS compliant environment, they're by default, they are authorized. So you might have a level of default authorization. You need to justify that to yourself and have a risk process around it. Um, the second way of doing authorization is the workflows we've looked at. Can you do a pre-authorization? And you can probably do this with all first-party scripts, whereby it actually runs through a workflow and somebody works out, yes, we want to add that script to the website, and there's a change control process, ideally that follows the change control process in, well, they changed the numbers, didn't they, from 3 to 4? I think 6.5 is change control in version 4. I'm sure someone will correct me if I'm wrong on that. So yeah, so could it follow even the PCI DSS change control process? And then finally, a post-change authorization process, i.e., you notice the changes happen, and then, or you very quickly notice the changes happen, almost in real time. And then you say, okay, there's a change happen to some JavaScript. Can we authorize this, or do we need to get it off the website quickly? And so what, in terms of post authorization, you'd end up with a workflow that looks something like this: is you'd have someone think that detected a new script had appeared, and you would send an alert. You'd ask information security to check it wasn't malicious. And if it was, like, you'd remove it from the page. And then if it wasn't malicious, you document its necessity. You'd then work out whether it was authorized. If it wasn't authorized, you could remove it from the page. And if it was authorized, you'd record the details of the approval. You'd update the inventory, and you wouldn't need to add it to the page because it's already there. Um, for a change script, you detect the change had happened. Again, you'd send an alert to say, hey, there's a change to a piece of script that's there already. You need to check it's not malicious. Again, if it is, you remove it from the page. If it's not, you work out whether the behavior or functionality of the script has changed. Is it a very simple change, like someone's just added a comment, or they've added some more spacing, or they've added some routines that don't change what the script does? Well, if the behavior and functionality hasn't changed, and I'm really sorry that I had to cross the lines in the flowchart. As you'll see in a second, there was no way of like doing the swim lane diagram without crossing. I've done it in a different color, but yeah, if the behavior and functionality hadn't changed, then you could just update the inventory. We noticed the change. There was no behavioral functionality change. There's no risk to this change, and it's been updated. If the behavioral functionality had changed, you need to redocument the necessity of it. You need to work out now whether that new functionality and behavior was authorized. If it wasn't, remove the script from the page. And if it was, you'd update the inventory and record the details to the approval. So by having 3 different classes of authorization for different first party, third party, new, and change, you can probably find a way of meeting the requirements in PCI DSS and stopping malicious attacks to your website, and stopping the marketing department and the digital department and developers trying to like not be your friend and not tell you when they're changing stuff. Because I appreciate that if you've got two scripts on your website, the requirements as written are really dead easy to fulfill. If you've got lots of scripts on your website and they're coming from third parties, the requirements are really hard to fulfill. Now, if you can't use CSP and SRI, you'll probably need to invest in some tools. And I'm going to talk very quickly about the 3 classes of tools that there will be. But I want to say this really important thing first is, do not even think about buying a tool until you've done that process mapping and understood how your first party scripts get on the page, how they get changed, how third party scripts get on the page, how they get changed. Because then you have a really good picture of where you can use CSP and SRI if you want to, where you can't use CSP and SRI, and what you'll need a tool to do. Now, when it comes to tools, there are 3 different sorts. There are proxies and content delivery networks, scanners, and agents. I'm going to very quickly give you an overview of all 3 because I hear lots of confusion in the market between them. A proxy or a content delivery network. And by content delivery network, I mean Akamai or Cloudflare or organizations like that, where they host they host a copy of your website nearer to your consumers' browsers, and they serve it to the consumers. So they sit between your web server and the browser. They can detect changes very easily in first-party scripts because they see all the scripts that go past that are first-party. Some of them will also go off and pull third-party scripts and verify them. They can create an inventory because they can see what the HTML is, And they can also do some pretty clever dynamic content security policy management for you. So those are proxies and CDNs. And if you use a proxy and CDN, it's probably worth looking at them. The second thing is scanners. And this is not like, if you're in the PCI world, this is not an ASV scan. This is not a vulnerability scan. This is a special sort of scanner that emulates a consumer browser, because the requirement says as delivered to the consumer browser. So you can think of it as a headless, we think of it as a headless browser. It's like a bot, effectively. It will visit the website, it will load the web page into a browser, it will then load all the third-party JavaScript into the browser. It can then make an inventory for it. It can look, it can see when there's been changes. But they're quite hard to configure. I personally have used this to protect my payment pages before. You have to teach the scanner or the bot the path to checkout to get to the payment page. So they have to typically buy something or get something, put it in their or search for something, select it, put it in their basket, go to the checkout page, and then they can, and then go to the payment page, and then they can read the contents of the payment page. So they're not easy to configure, but there's certainly one solution. And you, the requirement was deliberately written to be technology neutral. You can meet it with a scanner, you can meet it with a CDN. The difference is how your organization manages JavaScript. And then finally, you can use agent solutions. Agent solutions provide you with a JavaScript agent that's loaded first into the page. And then that effectively create, well, the way that the JScrambler does it, it creates a sandbox. It can effectively manage any other JavaScript that's loaded. It can watch what other JavaScript does. It can therefore then send telemetry back to give you the inventory very quickly. It can kick off or have an authorization workflow. Some agents, a couple of them in the market, including JScrambler's web page integrity, will block malicious behavior as well as, so it goes above and beyond the requirements of the standard. Standard doesn't require this, but it's quite good. It will block any malicious behavior. And so those are agents. So you can implement the requirement with CSP and SRI, which is free, but hard when you've got third-party JavaScript. You can also get tools like scanners, like agents, and like proxies and CDNs. We've reached the end of the presentation now, so I have got the summary slide of stuff that I think you should remember. So the first thing is that in complicated, sophisticated econ websites, managing JavaScript is, well, it's hard. The more JavaScript you have, the harder it is. The more third-party JavaScript you have, even harder it is. The aim of the requirements was to get organizations to consciously remove JavaScript from their payment pages, which reduces the attack surface. And that's actually the most important thing you can do. The first thing to do when you're trying to implement these two new requirements is to map the business processes and work out who owns adding first-party and third-party JavaScript to your econ website and to your payment pages. You will probably need separate processes to manage this for first-party and third-party, for changes and for new scripts. And you will probably need to implement 3 different types of authorization: a default authorization, a pre-adding to the site authorization following some change control process, and then a, oh, we noticed a change, let's make sure that change is an authorized change, and then authorize the change. And then finally, although JScrambler is obviously in the business of selling our product web page integrity, don't buy a tool until you understand your business processes. So I'd like to, I'm sorry, I'm 3 minutes over. I've said I'd be half an hour. It's 33 minutes past the hour. Thank you for watching. I hope this has been useful. I'm going to be here now for a good 26 minutes if there are any questions and answers. I don't know if you have to type them or if I can hear them, but we'll move it into Q&A. If you fill out the form on LinkedIn, you'll get a copy of the presentation and you can see this recording on demand. You can show it to your colleagues if they want to know. If you'd like a demo of JScrambler's web page integrity and how it works, the links on the link is there on the website, jscrambler.com. Request-demo, and then there's our email address, our website, and our telephone number. And we'd be more than happy just to chat about some of the complexities of managing JavaScript. We've been doing this for many large companies for a lot more years than PCI DSS has had these requirements. So thanks, and now let's open it up for Q&A. I don't really have any music I can play while we're waiting for someone to ask the first question. Right, Giorgio, I'm going to give you a quick round of applause for asking a question. Thank you. Um, it's a really long. Hang on, I'm scrolling now. It's Giorgio's answer. Can everyone see the questions? So it's a really great question, which is, what's the advantage of using something like JScramblers, web page integrity over a homemade open source or a custom application? It's a great question, Giorgio, and hi. I think yeah. Um, the answer is I'm going to give you like three answers, right? One of them sounds really like snarky, which is we've been doing this for 10 or 11 years. We're very good at managing JavaScript. It's probably going to be better than the homegrown thing. Similarly, there is a good open source thing. It was done by the guys at Target, people in the States. You remember Target? Yeah. Target, and they have an open source way of doing this. It might be okay. We've not evaluated it. I mean, the advantage is the same when you buy any commercial software. It's got support. It's got a team of developers behind it. It's going to be continued to be supported. And web page integrity definitely, it's a lot of testing. It works. More importantly, it can block malicious behavior. I know that's not the requirement, so it doesn't quite answer your question of like, can you meet the requirements? Yes, you can, but actually, for protecting your customers' cardholder data, um, meeting the requirement and then going above it by blocking malicious behavior is good. And I think actually you picked the answer, you picked the point in your question, is if you have third-party JavaScript, then any of the open source or homegrown tools, you're going to end up almost rewriting the functionality we have unless you implement it in a scanner. I mean, you could write something that curls everything, but technically the problem with that is a lot of JavaScript is I'm trying to find the right word and failing abysmally. So I'm going to just tell you what it does. A lot of JavaScript will customize itself dynamically. So it'll say, oh, I'm on a browser that's set for Spanish. I'm going to do something like this. Oh, I'm on a location of an IP address that's in the UK. I'm going to change this. For instance, I'm going to pull in a different payment service provider script. So whatever you do, you have to take into account all of these different options. Whereas an agent that sits in the browser, because it's getting telemetry back from every single browser session, sees all these different variances. The second thing is about how criminals will block it. We've always spent a lot of time making sure that our agent is not susceptible to attack. We wrap it in some tamper detection and tamper aware JavaScript, so that if someone tries to disassemble it or remove it, we're alerted and the merchant's alerted really quickly. That might be harder to do with a homegrown thing. Um, there's a question which is there a tool or approach you would consider for nested iframes? So like a parent of a parent. I God, that's a really good question. I don't know about that. Obviously, the parent page can't see into the iframe, um, and that's one of the great things about iframes is it mostly gives you isolation. There is actually a bug that stops that happening all the time, but mostly gives you an iframe. So I'm sorry, I don't have a great answer for that one. Uh, Great question, which is I use my payment provider's iframe to process payments, so the website doesn't store, process, or transmit cardholder data. Do these two new requirements apply to you? Unfortunately, they do. The PCI SSC, in its wisdom, added them to apply to the parent page if you're using SAQA, and if you are using an iframe solution from your payment service provider, you would be using SAQA, and these two requirements were included in SAQA, and there's a special applicability note that says they apply to the parent page, the one that hosts the iframe? Great question. Um, and scrolling, and that was the last question. Okay, I think we had 8 minutes of questions. That probably gave everyone time. If you think of a question afterwards, then do feel free to reach out and contact us. As I say, I've been worrying about this and thinking about this for a long time. The people at JScrambler know almost everything there is to know about protecting JavaScript. So if you want to ask any questions or want a demo, get in touch. Otherwise, thank you very much for attending today. I hope you have a good rest of day if you're in North America, and a good, not much left of the day if you're over in Europe like I am. Thank you very much for your time. It's been a pleasure. And we hope to see you again, because we're going to do some more of these, like general PCI DSS webinars. Thank you. Bye.